All right, so yesterday we looked at different properties of logarithms. Now we're going to look at solving some logarithms and exponentials, I guess. Okay, so the first method that we're going to look at is switching to log form. Okay, so we have two examples. So the first one says 3 to the power of x minus 2 equals 12. So before you solve or switch to log form, you have to have an exponent or a base and an exponent equals something. So you need to have, let me just write this like right here. So you need to have a base to the exponent equals something. Right now we don't have that. We have this minus 2. So we need to take this minus 2 and get rid of it. So add 2 to both sides. Add 2. So then you have 3 to the power of x equals 14. So we have a base, which is 3, an exponent, which is x, equals something. Okay, so now we can switch to log form, which is what you did earlier in the week. So we're going to take log base 3 of 14 equals x, and then you plug this into your calculator. So put into calculator. Okay, so then, get rid of that. Okay, same thing over here. So do we have a base? Yes. Do we have an exponent? Yes. Is there anything else being added or subtracted? Well, there's this minus 1 up here, but that's part of your exponent, so it's actually okay. So we can go ahead and switch it to log form. So we're going to have log base 3 of 2 equals your exponent, which is x minus 1. Okay, so we're trying to solve for x. We're not trying to solve for x minus 1. So we need to add 1 to both sides, plus 1. So now the biggest mistake people will make is they will take this 2 plus 1 and make this a 3. That is not what we're doing. You have to put this into your calculator first and then add 1. So we'll have log base 3 of 2. So all of this, put that into a calculator, and then plus 1 equals x. So then put this into your calculator. And on Monday, Mr. Stemper should have showed you a calculator to use. Okay, okay, so that was our first way to solve. And the next way to solve is to switch to exponential form. So we have log base 5 of x equals 3. So we need to switch this to the other form. So we'll have 5 to the power of 3 equals x. Put that one in your calculator. That one actually no. That's going to be 125. So x equals 125. So now this one, it has a weird 1 here, and that's okay. So let's see what it does. So if we switch this to exponential form, we'll have 2 to the power of 3 equals y plus 1. Okay, well, 2 to the third, that's 2 times 2 times 2, which is 8, equals y plus 1. And then you just need to subtract 1 from both sides. So minus 1, and we get y equals 7. Put 2 there. That was the second problem. Okay, then we have, we're going to combine what we did yesterday and this solving together. So we're going to use some properties first. Why does that look so wrinkly? I don't know. Okay, so before you can solve, everything has to be in a single logarithm. So this has 2 logarithms, so we need to condense it down to 1. So they both have log base 3 and log base 3, so we can write log base 3. And then if this is addition, this is multiplication, so x times 5 is really 5x equals 4. Okay, and then we need to write it in exponential form. So we'll have 3 to the power of 4 equals 5x. 3 to the power of 4 is 9 9 times 9, 81 equals 5x. Divide both sides by 5. And you get x equals 81 divided by 5. You can type it into your calculator and get a decimal if you would like. I'm just going to leave it like this. Okay, so now we have another one. All right, this one, we've got log base 2, and then we have 3 log base 2. So right now they are not the same. So we need to take this 3 and put it up on this 3. So when I rewrite that, I have log base 2 of x plus log base 2 of 3 to the power of 3. So I took this and I put it up here, equals 5. But now we have the same log. So we have log base 2, log base 2. So we can condense that into a single logarithm. So we have log base 2, 3 to the power of 3. This equals 27. So 27 times x is 27x equals 5. Rewrite it in the other form. So we have 2 to the power 5 equals 27x. 2 to the power of 5 is 2 times 2 times 2 times 2 times 2. So we've got 4, 8, 16, 32. So this is 32 equals 27x. Divide both sides by 27. You get x equals 32 over 27. That is that answer. Okay, then I wanted to do a few problems for my homework. So let's just pick, we'll do like 3 of them or so. Okay, so we'll do number 4 first. Okay, so this one, if it's already written in exponential form and you can't do it on your own, then you know it has to go to log form. So right now we have a base and we have an exponent, but we need to get rid of this 2. So we're going to subtract 2 from both sides. So we have 4 to the power of 2x minus 1 equals 6. Okay, so we need to write this in log form. So we are going to do log base 4 of 6 equals 2x minus 1. Okay, so now do not forget, you have to put this into your calculator to get out some number before we finish solving. So give me 30 seconds. Okay, so log base 4 of 6 is really 1.292. 1.292 equals 2x minus 1. So now to solve, you're going to add 1 to both sides. So plus 1, go up over here. So that'll give us 2.292 equals 2x. Divide both sides by 2. And you'll get x equals 1.146, I believe. So that's number 4. Let's look at, okay, let's do 7. No, there's my dog. Here's my dog. Say hi, Riley. Okay, go away. All right, number 7. So right away we see that there's 2 logs. So if there's 2 logs, we know we're going to have to condense them to make it a single logarithm. So we do have log base 3 and we have log base 3. But we also have this 2, so we need to move this 2 up top here. So we're going to have log base 3. 2 squared is just 4, so I'm just going to write 4. And then we have plus log base 3 of x plus 2 equals 4. Okay, so then go ahead and condense this down. So we'll have log base 3. This is addition, so we really need multiplication. So we're going to have 4 times x plus 2 equals 4. Okay, so we need to distribute this right here. So we'll have log base 3 of 4x plus 8 equals 4. Now we can take this and write it in exponential form. So 3 to the power of 4 equals 4x plus 8. Go over here. This is 81 equals 4x plus 8. So if we subtract 8 from both sides, we get 73 equals 4x. Divide both sides by 4. Get x equals 73 over 4. Okay, and then the last one, let's do 9. That's a subtraction one. We haven't done one of those yet. Okay, so we have log base 3 and log base 3. 2 logarithms, but we need to make it a single logarithm. So since it's subtraction, that's really division. So we'll have log base 3 of x. The first one goes in the numerator, the second one goes in the denominator. So over 2 equals 4. Rewrite it in exponential form. So we have 3 to the power of 4 equals x over 2. 3 to the power of 4, that's 81, equals x over 2. To solve for x, we multiply both sides by 2. So we get x equals 162. And those are some examples of solving. So we did 3, you've got 7 left, and that is it.